So the next
What about
one,
that one with the H and a?
yeah, let's see. Okay. Um, do you want to take a look at this one or a different one?
Yeah, we can look at this one just to see how you got that answer right. It's F.
Yeah, so this one I think is also a wrong answer when I
Oh
took the
yeah, yeah.
picture. When I
I
took the
hope we
picture, yeah.
switched it. If not, yeah, you went to the last one, right? It was 4 and 4.
Uh,
I thought, or the third one, or one of the.
well, it was a different one. So the idea is first figure out the point where they meet. So that's right here. Now the x part of this point, because we can say this is an ordered pair for this point. The x part of the point is -3 because that's just on the x-axis.
Okay.
And so then what's the y-coordinate for this point?
It would be -4.
It would be -4 because that's on the y-axis, so you're just tracing it out. So
Okay.
-4. Now, for these parentheses, like here and here, whatever you put on the inside has to be the x-coordinates. Always x's. You're always putting x's in there. So this is x, this is y. So the spot where f of something equals g of something is at this point, and you're only allowed to plug in x coordinates. So it's this answer. Because f of -3, well, if I started here and I went back 3, 1, 2, 3, and then I traced it out to my blue line, I would get -4. And then if I did the same thing with g of -3, again, 1, 2, 3, and then trace it out to my red line, still the same point, still comes out to -4. So f of -3 is -4, g of -3 is -4, so that means f of -3 equals g of -3. Because
Okay.
they both equal -4. Here's like something that wouldn't work. If I said, let's see why this is wrong. So f of -4, let's figure out what the y value is for that. F of -4. Let's see what the y value is. So if I went -4, 1, 2, 3, 4, and then I found my y value, I'm going for f, so that means I have to trace it to my blue function. The y value would be -6. Does that make sense? Does that make sense to you? Hello?
Mm-hmm.
Oh, I can hear you now.
Okay, cut off.
Does this part
You
make
were
sense?
finding you went to the -4 and went down, so it would be uh,
1, 2,
to find
3.
the x value, right? You hit the -6.
Well, I already know the x value is -4. So to find the y value, I go from the middle to 1, 2, 3, 4, and then I just trace it until I touch my blue line
To
again.
the okay, yeah, yeah.
And
So you
so
got the
now the y
-6.
value lines up with -6. Yeah?
Yep.
Okay. So now, g, I'm just going to figure out what that is.
-3.
What is g of -3? Well, that
-4,
means,
right?
yeah, we already did that. It's -4. So they don't equal each other.
Okay, they have to equal each other.
Yeah, because we're saying these two things equal each other only because they are equal to the same thing.
Oh, okay.
So if they don't equal the same thing, then they can't be equal to each other.
Right.
So that's the idea there. If we did, Actually, let's look at that last one that's kind of like it. Let's see this one. And let's, I think this was the last one that we were looking at. But now, it's first you're trying to figure out, okay, well, this is where the two functions are going to equal each other, because that's where they touch. So I just need g of, well, -2 gets me to this point for the red line. So g of -2, that equals 4. G of -2 equals 4. And then f of -2, because that's where that line meets. So f of -2 also equals 4. And since they equal the same thing, that means they equal each other. So
okay. Oh, simple.
I'm trying to think of. Okay, so the question that I'm having now is like, when would, say, like, so right here, these are both the same number, right?
Yeah.
That means they intersected. Like, it's asking like where they intersect or what statement is true based on the graph. That's when they intersect. There is, actually, I'm not going to say it until we run into it because it might be confusing at this point. So well, let's do that other inverse problem, I think it was. This one. There's kind of a lot of steps to this one, but I mean, it's not too weird, but let's see.
All right.
So on this one, whenever it says to find the inverse, that means switch and solve. Switch and solve. And solve just means get the x by itself or get the y by itself. So we'll see. Maybe it'll be, I think it's switch and solve for y. So that just means get the y by itself. But you'll see what it means in a second. So the first step is we have f of x equals 2x minus 10. The first step is to change f of x to y. So I'm going to change this to y equals 2x minus 10. This is the steps to find an inverse. So change that to a y, so I just changed it out. Then the second step is to switch x and y. So I'm going to write x equals 2y minus 10. Just like pick them up and switch them. And then solve for y. That just means get the y by itself. Oops. So if I'm going to get the y by itself, I need to add 10 to both sides. So I have x plus 10. I can't combine those, so I just have to write it sideways. X plus 10. And then that goes away, and so I have 2y. And then divide everything by 2. So like divide this by 2, divide this by 2. So that goes away, and now I have y equals 1/2 x. That's the same thing. X over 2 is the same thing as 1/2 x.
1/2.
And then 10 divided by 2 is 5, so plus 5. And that's what they have there. And then you just change this back to h of x. So I guess the third step would be solve for y. Is there a different way to do this? Let's see. So one way to do it that would be different is like if you plugged in for this one, let's do it in this color. If you plugged in f of, let's say, 2, all that means is you take this x and you change it to a 2, because that's what we did here. Change it to a 2. I'm plugging in 2. So this, I would say 2, and then change the x to parentheses, and then minus 10. I plug in a 2, so I'm going to plug in a 2 here. And then follow the order of operations. Parentheses first, there's nothing to do inside there. Exponents, there are no exponents. Multiplication, so 4 minus 10. And then 4 minus 10 is negative 6. So this equals negative 6. Now what you could do, an inverse, by the definition, means, well, if we plug in something here, we get something out. If we plug in the output to the inverse, it gives us back what we normally would have gotten. So like, this is, I think, really, really confusing, but if the input for this is the output for the inverse, and the output for this is the input for the inverse. So like they're switched around. So if now this is probably too much, but if I plugged in a negative 6 here, 1/2 times negative 6 plus 5. If I plug in that negative 6, I should get out a 2, because these two things are inverses of each other. So let's see. 1/2 times negative 6 is negative 3. And then plus 5, that's positive 2. And that's what we wanted. So that's the other way. You know what? When we get to it, we'll see what happens. Yeah, I don't know. It's
like a nice
it's a lot, I feel like, but let's continue with the rest of them, and hopefully with the ones with the graph, we can figure those ones out.
This is one of them? No, right?
Okay, this one's just straightforward. You plug in an 8. So instead of f of x, you would write f of 8, and then equals, and then 6 parentheses 8, and then minus 4, and you only figure out the right side. You don't have to do anything with the f of 8. But that's really what it's asking. What is f of 8?
So it'd be, okay. Would be 44, right?
Yep. So all that means, it's saying what is f of x? F of x you can think of as the output. The function name is also what you can call the output. So like f of x is the function name, but f of x is also the output. And it's saying what is f of x? What is the output when x is 8? So if you plug in 8, because x's are the same thing as the input, if you plug in 8, what is the output? And it's 44, because 6 times 8 is 48, and then minus 4. That
and
one's
if you
a
were to
simple
write
one.
out, you didn't have to put you just left the right side alone, right? F. You wouldn't put the 8 where the x is, because you're just going to do the right side?
Yeah, I mean, they could have written out, instead of just 44, They could have said f parentheses 8 equals 44, and that would also be correct.
Okay.
But I mean, it's just asking you what f of x is when x is 8. So just be aware that they could write it f of 8 equals 44, but it's the same idea.
Right. That one wasn't too bad.
Okay. All right, so
It's not B.
no, let's look at that first one. What does that first one mean? Hiroto's plan costs more than Emilia's plan when more than 50 texts are sent. So the x-axis, that's number of texts.
Yeah.
And for the x value, the x coordinate, when they cross, that's 50, right?
Yeah.
So at 50 texts, the y value is the same, whatever the y value means.
Yeah, that's where it crossed, right?
Yeah. Total cost. Okay, so
22,
if
yeah, 22.
yeah, 22.5. You can see on the y it says in those parentheses.
Right, yeah.
22.5. So Hiroto's plan costs more than Emilia's plan when more than 50 texts are sent. So that means just to the right of that intersection point, just to the right of where they cross, it's saying Hiroto's plan costs more. But Emilia's is higher on the graph, right? Just after. So A is not true. Does that make sense to you?
Yeah, because it's way higher.
Yeah, so if they switched the names around, then it would have been true. Both plans cost the same when 22 texts are sent. That's also not true. When do both plans cost the same? At how many texts?
At 50.
At 50 texts, okay. Emilia's plan costs more than Hiroto's plan when more than 22 texts are sent. That's also wrong.
Yeah, because it should be way below.
Yeah, it's what if it's more than what? Like Emilia's plan costs more when it's more than how many texts?
The 50 texts.
The 50, yeah. So they're trying to like mix around the x and the y values for that answer. So then the last one, both plans cost the same when 50 texts are sent. Yeah. Does that make sense?
Yeah, for sure.
The ones with the graphs I feel like will be easier on this one. We'll see about the inverse stuff though. Okay. Two functions are graphed on the coordinate plane. Okay, so without even looking at the answers, when it says which represents where f of x equals g of x, that little equation, f of x equals g of x, that means you're looking for the point or points on the graph where both of the different colored lines touch. And there's two spots, right?
So like -4 and, well, I mean +4 and -4.
Yeah, so the x value, what would the x value be for that left intersection point?
The -4. Right?
-4. So it would be, so that x value is important because when you plug it into the f of x, if you use that function notation, you're only going to be using the x. So it should be f of -4 equals g of -4 because the y value is both 4 at those points. Does that make sense?
Yeah.
So f of -4 and g of -4. What's the x-coordinate for the other point where they cross?
0, right?
It's 0 because, yeah, you don't have to move. If you're starting at the middle,
Just go straight up.
you don't have to move left or right. You just go straight up to 4. And both of them equal 4, so yeah, f of 0 equals 0. So it's that second one. Okay. If you had to guess on this one, just guessing, what do you think? Based on that last one that we had with the inverse. Do you remember?
I'd say it's it would be it's gonna have a fraction in it. Like I would say it's A, right?
So it does have a fraction in it. The other one had a fraction in it too. It was like 1/2 x plus 5. It's going to be D on this one. The way you can think of it is an inverse function does the same stuff as the other function, the regular version, except for it does it backwards. So it kind of undoes what the regular function does. So the regular function here is f of x. If you plug something in to f of x, really it just means take whatever you plug in and multiply it by 4. Does that make sense for the regular function? Whatever you plug in, you're just multiplying it by 4?
Yeah, that'd be x, right?
Yeah, so like if you plugged in 2, then you take that 2 and you multiply it by 4. That's what...
That's that.
Yeah, that's the regular function. That's what it does. It takes things and it multiplies it by 4. The inverse function does the opposite of that. So the opposite of multiplying by 4 is dividing by 4. And that's why you'd have the 1/4 x, because that's the same thing as like x over 4.
Oh, okay.
Those ones, they get more complicated when there's like a plus. Like if it's 4x plus 2, it gets a little bit more complicated. But if that shows up again, we could go over it again, or like we could we could talk about it after. But the basic idea is they undo each other, the regular function and the inverse. So we'll see more hopefully, or we can talk about it more afterwards if you want to.
Just to do the opposite, kind of.
Yeah. This one is not the opposite because it doesn't say any inverse. You go ahead and try this, and then I'll check it.
So if x, okay. B13, right?
Yep. All that means is just like fancy words to say plug in 10.
Yeah, that one. Those are easy.
Yeah. Cool. So you think it'll be is this the test now?
Sweet. Yeah, so it's going to pre-prep for the test. So I got 15 questions of that whole...
All of the topics.
That whole... Yes.
Hello?
Hear me?
Oh, there we go.
Oh.
All right. Wait, you cut out what?
Oh, no. I was just reading the...
Oh, okay.
I was just wondering if you heard me before.
So, why is the product of a rational number and an irrational number irrational? Because the product is always non-terminating and non-repeating. That's what it takes to be irrational.
Rational, right there.
Because the product is always a fraction. No, if it was a fraction, then the answer would be rational. So it can't be that one because the product is always a negative number. Negative numbers could be rational, so it's not that because the product is always a repeating or a terminating decimal. That means also rational. So it's the first one.
Yeah.
That's the only definition of irrational. All the other ones mean rational.
Which of the following expresses?
Okay, so the way I would do this, all of them have a 2 in front, right?
Yeah.
So that's just the 2.4 with the bar over it. The 2 is the same thing as those other 2's. So the 0.4 repeating
Okay, I'd have to just
comes from the fraction part. So
one
just
divided.
yeah. And then see which one gives you 0.4 repeating.
Would be the last one.
Yeah.
2.4. Well, that's a good way of doing it.
Yeah, just figure out the whole number part, and then the repeating part is just a fraction. Okay, so this is like what we just did.
Yeah. It would be a 0, right? Because, well, no, this one's moving 2 to the right.
Mm-hmm. And what you put on the inside of those parentheses are always the x values.
And then same with the other ones,
Mm-hmm.
2. But then for the x, it should be 0, 0.
No.
For the y.
For the y value, it's like f of 2 equals 0, and g of 2 equals 0. So their y values are both 0 when they cross, which means f of 2 is going to be the same thing as g of 2. It's always the x values that go in the parentheses there. So like if you're like thinking about, but they meet at 0, but they meet at 0 for the y values. So f of 0 equals g of 0. That's not what you would say.
F2,
so it's the
G2, right?
It's that f of 2 equals g of 2.
This is the ones we did last time.
Mm-hmm.
-2. And 3, but I don't see the.
So
which one can be?
So remember the way. This is not timed, right?
Okay, this is I got you. No, I got you. So it's gonna be the 1 and then the 3 up. So 1, 3.
Yes, there you go.
Yeah.
Yeah, because that bottom one with the -2, the ordered pair for it would still be 1, -2. It's just not one of the answers that they tell you.
Yeah, this one's not timed. It's just like a review.
Cool. Do you know what it's asking you to do?
Look at the function. So no.
Okay, so they're asking you to go through each one of the answers and plug in the x value and see if you get the y value. So for the first answer, what would be the x value? Do you know?
Do I have? What do you mean for the first answer? So 0, 18?
Yeah, which is the 0 the x value, or is the 18 the x value?
The 0.
The 0. Okay, yeah, because it's always the
The left.
first coordinate. That's the left coordinate. That's the x. So if I take y equals 16 plus 0.5x, if I take that and write it down, y equals 16 plus 0.5x, and I plugged in a 0 because that was the x coordinate. If I plug it in a 0, do I get a y value of 18? Let's see.
Oh, okay.
Actually, I think we can share at the same time. What happens?
Can we?
Don't do anything. Let's see. Can you see my screen? Or no?
No, no. I don't know about the shrink it or.
Okay, never mind then.
No, it's not showing. So y equals 16 plus 0.5 times 0. And we're going to do the 0.
0.5 times
We're just
0.
gonna do it regularly, right?
Yeah, do that first. And then add 16. And you get 16, right?
Yeah.
But the y coordinate for that answer was 18. It doesn't match up, so that's not the answer. What that is saying is in the column, the x column, replacing that bottom x, if you replaced it with a 0, you would have to replace the y with regular 16. In fact, it's actually already there, 2 like rows above, 0 and 16. So that's not right. So 5 and
But we put 5,
19.5.
it should equal 19.5.
Yes.
Okay, I got it. No, because it equals 18.5.
Yeah, so that one also doesn't work.
So the third one works.
Yes. And we could try the last one.
We'll try the last one.
But it shouldn't work. So if it does work, we did something wrong.
Okay.
Yeah. Okay. Which statement describes the total amount a reward customer pays for 10 ounces and 12 ounces of yogurt? So I would even look on the graph before I look at the answers. For 10 ounces of yogurt, what's the price? And for 12 ounces, what's the price?
Same price.
Yeah, it's the same price.
$5.
Okay.
A reward customer earns 2 free ounces of yogurt because the total amount paid for 10 ounces and 12 ounces is the same.
That seems right because they're spending $5 whether they get 10 or 12. Maybe. Let's read the other ones. Well, B
I don't know, but
is not true. It says a rewards customer pays $5 per ounce because the total amount paid is always increasing. Well, there's a spot where it's not increasing, that flat spot.
that one's on.
Yeah, but also it's not $5 per ounce anyway, because if you got 2 ounces, you should pay $10, and then 4 ounces, you should pay what, $20 or whatever. So that one doesn't work. A reward customer pays $20 for 10 or 12 ounces of yogurt. That's automatically not true.
Yeah.
Because $20 doesn't even show on the graph because it's the Y. A rewards customer earns 5 free ounces of yogurt because the total amount paid for 10 ounces and 12 ounces is the same. Okay, so that it could be that one or the first one. Ounces of yogurt.
Let me read the each sentence describes the total amount.
Okay, when we read that first answer, a rewards customer earns 2 free ounces of yogurt because the total amount paid for 10 ounces and 12 ounces is the same. That means, that means if they buy 10 ounces, they get 2 more ounces for free. So they're paying $5 for the 10 ounces, but they get 12 ounces, 2 more ounces. I think that one's the right one. If you did 5 free ounces, it should be 10 ounces all the way up to 15 should be the flat spot. But yeah, it's that first one. That one's kind of tricky, but I feel like maybe you could figure that out. Function f of x is shown on the graph. If f of x equals 0, what is x? Okay, so this one is kind of backwards. It's not telling you to plug something in, but it is telling you to figure out where the y value is 0 on this graph. And there's a couple different places. Do you understand what I'm saying, or should I show it to you on a picture?
Not -6?
No.
What is x? Oh, because it's...
It's asking what the x is when the y is 0.
Yeah, so it should be -2, 1, 3 only.
Yes.
But that's the time that it keeps hitting the
x-axis, and when you hit the x-axis, your y value is 0. That's the answer. -2, 1, and 3. Okay, this one's flipped the other way around. Now you're plugging in an x, and you're figuring out what the y value is. So when x equals 0, what is the y value?
-6.
Yes.
Well, it's just -6. Right? That's where it hits the y.
Mm-hmm. Those ones, I feel like if you do enough of them, they get really easy. But at the beginning, I feel like they might be confusing. So we'll see if they have more.
Yeah. They're not actually bad, though.
So product of a rational number, non-zero rational number, at an irrational number can always be written as, I would say, an irrational number, because that was one of the rules. So which one of those means irrational?
A non-repeating, non-terminal decimal.
Yep. That's the only one that means irrational.
Yeah, the rest of them are rational.
Okay.
So this is the inverse function. This is the one with the plus sign in it.
Yeah, so like here, this function, when you plug in a number, you add 3 to it. The inverse does the opposite. So what's the opposite of adding 3?
Dividing.
The opposite of multiplying by 3 would be dividing.
Okay. So you would, yeah. So You would subtract it.
Subtract. So which one do you think it is?
It would be B.
That one also divides by 3. The 1/3 is dividing by 3, but we don't multiply by 3 in the original function at all.
Oh, okay. So it's just I see.
Yeah, this
so
one only it only has
C. Yeah.
Yeah, one thing happening. So
Oh wow.
yeah, it's the answer is C. Because so like if you had 2x plus 3, then you would end up with a fraction because there's the 2 times something. So
I get it.
You got to divide by 2 at some point, and then you would also have to minus 3. So yeah, it's only adding the 3. So the opposite of that is just subtracting it.
Yeah, see, those ain't bad. Once you get it, I guess.
Oh, these ones I feel like were confusing.
Yeah, these are one of those ones that we gotta. We gotta switch it to.
Yeah. Approximate speed in miles per minute. Mia jogs 3 kilometers in 20 minutes. There are about 0.6 miles in a kilometer. So we have to do kilometers to miles. So 0.6 kilometers equals, no, 0.6 miles equals 1 kilometer. So that means either we have to take those 3 kilometers, we have to take it and multiply it by 0.6 or divide by 0.6. We got to figure out which one to do, either multiply or divide. Do you know which one to do right away?
I think multiply, right? That's what we were doing yesterday.
Yeah, on some of them we multiplied, and then on some of them we divided.
Oh, okay. This is doing yeah, so we're gonna divide them.
Well, I don't even know right now. I'm just gonna try it.
I thought you were trying to figure it out. Okay, so I'll just do both.
Yeah, and then see which one makes more sense. So, and the way that I'm thinking about this is miles is smaller than a kilometer. 0.6 miles in 1 kilometer. Does that make sense?
Yeah.
So the miles are smaller than kilometers. So let's try multiplying. 0.6 times 3. So 1.3 miles and or 1.8 miles is the same thing as 3 kilometers. Okay, if that was multiplying, I'm going to see what happens if I divide. So 3 divided by 0.6 is 5 miles. And the miles should be smaller. So 5 miles can't be equal to 3 kilometers because the miles should be smaller. So we multiply, so it's 1.8. For the miles, and then we have to convert the minutes. So 1.8 miles per minute. Oh, that just means it's already 20 minutes, right?
Yeah.
So now we have 1.8 miles in 20 minutes. To get miles per minute, all you do is just divide those. 1.8 divided by 20.
0.9.
Yeah. So here's the thing. I want to try and do another one like that. Let's say $2. Okay. €1 equals $1.18. All right, let me share something real quick. So this is just something that I looked up. €1 is 1.18. If we had, say, like Tom earns $15. Let's do dollars in 3 hours. How many euros per hour does he earn? So, to answer this question, do you think you can try it and then I'll check you, or do you want me to walk you through it? Because it's similar.
Yeah, Tom earns $15 in 3 hours. How many euros per hour does he earn? So he earns per hour. I would
So first, what we did in the other one, we changed the kilometers to miles. So here we would change the dollars to euros.
Yeah.
So try and do that and see which one makes sense, like for what you do.
So I did so I divided the 15 to 3, right? It's $5. That's how much he makes an hour.
Okay, so $5 per hour.
And then I times 5 times 118, and I got 5.9, which I don't know.
Let's see, 5 times 1.18 equals. So €1 equals $1.18. So the dollars are worth more. So you're saying 5.9 euros per hour?
Yeah. No.
Okay, that makes sense.
Oh, no. Yeah. I think, right?
I think so too.
That's how much he made in an hour, yeah.
Yeah. So the dollars are more in this. So the dollars, oh, it's backwards, isn't it? The dollars are less here. $5.
Yeah, per hour in America, right? But then how many euros? So he's making the 5 point. Oh yeah, it should be.
It should be less.
$1 equals 1/8. Yeah.
So this should be the euros. So this is like the rule that I'm thinking of. The euros are less than the dollars. So then the euros should be less than the dollars here. So
Yeah.
instead of multiplying, we shouldn't multiply. We should divide. So
but in real life, the euro is more, right?
So it would be the other way around. Yeah.
Okay.
But 5 divided by 1.18, 4.233 euros per hour. So what, like the takeaway is, whenever they give you a conversion, make sure you know, like, okay, the dollars is more than the euro. So for my answer, the dollars should be more than the euro when you convert it.
Okay.
So let's go back. Let's go back to the problem that we just answered, and then see if that rule holds up, because I think it should. So here, 3 kilometers, we converted that to miles, and what did we get? We got 1.8. So 3 kilometers and 1.8 miles. The miles is less than the kilometers. And if you read in the problem, 0.6 miles in 1 kilometer, the miles is less than the kilometers. So that rule holds up. So if you're like multiplying and that rule doesn't hold, then you just need to divide.
Okay.
Maybe we'll see. I don't know. Would we be able to do the test after this?
No, because she would have to unlock it.
Okay. But that's the rule. When you're converting, you look at the conversion that they give you, the 0.6 miles in 1 kilometer, and you see which one's bigger. So then after you convert it, that same thing should still be bigger.
I see. Yeah.
All right. Which one do you think?
It's not pi, and it's not the b all either, right?
Correct.
It's a.
Yes.
Because this one's not steady with the number like.
Right. It's just random numbers, and it keeps going on and on. And a is written with a fraction, so it's good.
So like this one, it would just be how many feet? So there's 60 seconds and freaking.
In a minute. So then, how did you? So to get 10 seconds to like how many tens fit into a minute? How many 10-second intervals fit into a minute?
6.
6. So it's like 10 seconds, 10 seconds, 10 seconds, 6 times. And if he moves 120 feet in each one of those 10-second intervals, that means he's moving 120 feet 6 times, right?
Yeah.
So then all we have to do is do 120 6 times, so times 6.
$720.
Yeah. Does that one make sense?
Okay. Yeah, that one makes sense.
Okay.
So it'd be the b.
Yep.
Go back to -3 and go up.
Yep, and back -3 and then up 2, and that's that top point. Yeah.
This is one of those ones.
Oh yeah, 1.44 per pound. Oh, there's the conversion. Kilograms in 1 pound. So the kilograms are smaller than 1 pound.
So at least you would use those two numbers, right? But we just got to know that the kilograms got to stay smaller.
What do I to the nearest cent? What is the price of the grapes in dollars per kilogram? Oh, this one's slightly different. I mean, if you just use those two numbers, I'm not sure it's.
I would say because it's 150 per pound, right? And then it's like it's almost 50 cents.
Sure, okay.
There are approximately in a pound, so it'd be like half price.
Yeah, okay. Oh, that makes sense. So, like, if you said like 150 in 1 pound, and a kilogram is almost like half a pound.
It'd be like 65 cents to the nearest, right? I'm not sure if that's correct. That was just kind of how I was trying.
I think it's backwards. per 1 pound. What did you do anything with the 144 and the 0.45?
No, not yet. Not yet. That's just what I was just looking at it.
I think you divide them. Because it's like, here, let me...
I did get 320.
Yeah, that's what I
Or
got.
3.2, right?
Yeah. Let me... 144 per 1 pound and 45. Okay. Let me share something real quick. It's all weird because they're slightly different. But it said 144 $1.44 per 1 pound, right?
Yeah.
And then it also said 0.45 kilograms is equal to 1 pound, right?
Yep.
So if these two things are equal, well, that's just like saying, I mean, 1 pound, oops, 1 pound is equal to 45 kilograms. So instead of putting 1 pound in the bottom, I can put 0.45 kilograms. And then that just means divide, and that's what it did. We'll see if that's right. I mean, that's how you got the 3.2, right?
Yeah.
And then it's dollars per kilogram, so like dollars over kilogram. So let's see if it's right. Sometimes it's tricky.
Yeah, it's just not going to show me. Just keep it.
Wait, what? It doesn't show you if you got it right or not?
It has on some, not all. It did pass, because if we didn't pass, it would have been like, hey, you need to freaking take this course.
Oh, take it again.
Yeah, but it didn't show me the score.
Oh.
Shit. Let me see if I can go to the previous activity.
Oh, it's not sharing, by the way. I don't know if you mean it to be or not.
Yeah, we got 100%. Yeah.
Oh, okay. So does that mean we have to wait for the...
Yeah, so I'll email her. I'll email her right now, like tonight, and then hopefully tomorrow she'll unlock it. See.
Okay.
Yeah, so she has to unlock it, and then it gives me like 3 attempts.
Okay. All right. Well, I should be available tomorrow, and
Yeah,
we can do it.
You don't have anything to do yet.
Yeah.
I got this one. I don't know if you. This will be the next one.
Oh, and you can actually like look at it.
This is the next course,
right?
So, yeah, we can start this one, and then we can do it whenever tomorrow. Whenever. Slope, intercept from a line, form of a line.
If you want to do that, we can do that now.
It's up to you. Yeah, you got time.
Yeah, let me say something about that.
Yeah.
And then we can look at that since it's only like 9 o'clock. So. All right, so slope, intercept, form of a line. So we kind of did something like this already before, but slope, intercept, form of a line, that's y equals mx plus b, where the m and the x, these are multiplied together. The m is going to be some number. So this will be some number. and that's the slope of the line. Slope of line. And then B is also going to be some number. And it's called the y-intercept. And all that means is wherever this line, when you graph it, wherever it crosses the y-axis. So where line crosses y-axis. So that's really all it means. So normally what you'll see, so like for examples, would be y equals 3x plus 4. In this case, the slope, m, would be just 3 because it's the thing in front of the x. It's not including the x. The slope is 3, and the y-intercept is just positive 4 because it's a 4 there. Another example would be like y equals 1/3 x minus 2. The slope would be 1/3. The y-intercept would be -2 just because it's minus there. So we consider it a -2. The slope intercept from the line. Okay. The slope, again, we talked about it a while ago, but the slope is the rise over the run. So this is like up and down, and then this is like left and right. So if I have just a graph, I'm going to say the slope equals 2/3, and I'm going to tell you that the y-intercepts, this is another example, actually. So I'm going to say the slope is 2/3, and the y-intercept is -3. And then I told you to like graph this. The way you could do it, shoot, move this. So if I told you to graph this, the way you could do it would be just by the definitions of what we have. The y-intercept is where the line crosses this y-axis. So I just go down 1, 2, 3. So I know that the line crosses this point somehow. I just don't know the slope of it yet, but I know it crosses the y-axis here. Does that make sense so far?
Yeah.
Okay, and then I follow my slope from here. Rise 2, 1, 2. Run 3, 1, 2, 3. That's another point, and the line is just going between them.
And it will continue on, right?
Yeah, and it continues on forever.
Yeah, 3, 2.
That's really the basic idea for slope-intercept form of a line. They give you the slope, they give you the y-intercept, and you can get them from a graph. Let's see what the problems are like.
Okay. Yeah, because sometimes I do this.
Yeah, sometimes they make you do it backwards. So WZ, do you see that line? The one that...
Yeah, the one to the left.
Yeah, it's like the bottom left line.
Yeah.
The having the same slope means that they're slanted the same. Like they're kind of like they're parallel to each other. If they have the same slope, they're parallel to each other, like railroad tracks. Does that look like it's parallel to you? Y, Z, and X, Y?
Yeah, because the one on the left is -3, and the one on top is 3 and 3, and they both look pretty straight. They're crossing over the middle of everything.
Yeah, I agree. I think that one is correct. Line YX. Okay, YX is the same thing as XY, so it's still that top right line.
Okay. ZY has a greater slope than ZY.
Okay, that one is not true. Um, greater, like for a slope to be greater, means it's much more steep. Like if it was a mountainside, you'd fall a lot harder. If it had a big slope, but also XY, the line XY, that slope is negative because from left to right, like if you're like when you're reading or like if a guy's walking from left to right on that slope, he's going downwards. So that means it's a negative slope. XY is a negative slope. And then ZY is going upwards from left to right. So that one's a positive slope. So the negative slope can't be greater than the positive slope. It's like a negative.
I see, yeah, it's coming from the top to the bottom.
Yeah. So that one's not true. Let's see. XW has a lesser slope than YZ. What do you think on that?
I agree, just by looking at it.
Yeah, so YZ is steeper.
It starts at the top, too.
YZ and XW. But do you see that YZ is more steep? Like if you're climbing from left to right, it would be harder to go up YZ. It'll be easier to go up WX or XW or whatever. So XW is a lesser slope. Yeah. ZW.
ZW has the same YZ. Yeah, that's true. They both land on -3, right?
Yep. Because the y-intercept is just where they cross the y-axis. XY has a lesser y-intercept. What's the y-intercept for XY?
Should be the regular 3.
Regular 3, yeah.
Yeah.
And what's the x-intercept for X?
That's kind of threw me off. Yeah.
What's the x or y-intercept for XW?
2.
2. So that's not right because 3 is bigger than 2.
Oh, yeah.
So we're good.
Shit, I completed.
Oh, it says can't.
I thought it was going to start pausing.
All right. Do you have a guess on this one, or
so let me. He makes $2 every time he sells a hot dog.
Yeah.
Why? So I would say it'd be B, right?
No, on B, that one's saying for every hot dog, because the hot dogs is the X for X hot dogs. So hot dogs
Okay.
are X.
X is the pickup. Okay.
So it's saying for when you're multiplying, for every hot dog, for every X, he earns $48. That one doesn't. That's not what it says. So it's either got to
X
be,
is the hot dog. Okay.
yeah, it's either got to be C or D. Because for every X hot dogs, he earns $2. So like if he sells,
It's D. Because you gotta add them.
see, but he's earning money when he sells a hot dog, right? He's making money when he sells a hot dog.
Yeah.
Um,
Like he already spent $48 every day.
yeah, so that's the
yeah,
minus. So it should be C. That's yeah, it's tricky on that, but it's he doesn't earn that; he spends it. So
yeah, he already spent it. He's just trying to see how much. You read it?
which graph could represent the leaf's height in feet as a function of time in seconds? So 0.25 feet for every second.
So it's one of these two for the starting. Right?
Yeah, it has to start at 12, right?
Yeah.
So which one? For every second, it's 0.25 feet. So in 2 seconds, should be half a foot.
Yeah. Yeah. 4 seconds.
It would be a whole foot. That's 2 feet. Do you see that or no?
Yeah, because it went down big time. Yeah.
It went down from 12 to 10 when it went 4 seconds. So like if you put an extra tick mark in between, it would be so that you would have 1, 2, 3, 4 on the bottom. And you count like 0.25, another 0.25 is 0.5, another 0.25 is 0.75, okay. Another 0.25 is 1. So in 4 seconds, it should have fallen 1 foot, but it went from 12 to 10, which is 2 feet. But on the other one, it's like halfway. When you get to 4, it's like halfway between 10 and 12. So maybe I think that one's it.
This one somewhere.
You're right though. They have to start at 12. It's just that it's like a weird decimal that makes it difficult.
Yeah, they don't graph it on there. So I guess you should know.
What is the slope? Okay. So this is, if you remember what we were talking about at the beginning.
What is the slope on the line?
And if you want me to share that picture so you can review it from what we wrote down in the beginning, let me know.
Yeah, you want to share it?
Yeah.
You got it.
And this will be quick too. So they have something written down, something that looks like this. The number right in front of the x, that's what the slope is. And then the other number is the y-intercept. So this part is the slope. So here, the slope is regular 3 because it's right in front of the x. Here, the slope m is 1/3. This is m. M is the slope of the line. So the slope is 1/3 because it's right in front of the x. So what is it on that problem that we have.
Okay. So the slope is 4/5.
Yep, that's it.
So that's it.
Yeah.
Wow. This would be kind of the same, right? I mean, obviously it's
Similar. Looking at just the picture, can you remember if the slope is positive or negative?
this is a negative because it's coming from the top
Mm-hmm.
to
Mm-hmm.
the bottom, so, and it does hit at 3, right? That's where it
Yeah, and
intersects.
that's why all the answers have that +3 there. Okay, so the only negative answers are A
The
and
negative
D.
2 and the
So the slope, remember, is rise over run. The rise meaning up and down, and
and then to the right.
yeah, the run means like left and right. So
So it'll be this one, right?
well, if you rise, yeah, yep,
From here, 1, 2.
mm-hmm, and then run 1, so 2/1. Yep, that one's not bad.
Yeah, that's
Same type of thing.
so it's a negative one again. Or
A
does it
negative
does this
slope.
mean
Yep.
negative? Is it okay? Even though it doesn't go down into the negative.
Yeah, still a negative slope because it's
So
coming from the top and getting smaller or getting lower as you go from left to right. So the
it's at
answers.
3,
Oh, okay. So it's
and that would be like this guy here. So
yeah, either A or D.
So it's this one here.
Yep.
Because it goes down 1 and then over.
Mm-hmm.
Cool. Yeah, I feel like we did this stuff on the last
We
course.
did in a like I don't know how many, a couple weeks ago, but hey, that's good.
Yeah, these ain't bad. I'd rather.
Okay. Um, the
20 cents per minute.
um, how will the graphs of the monthly costs compare? So like each month.
Yeah.
Well, each month, one of them has to pay just straight up $50, and the other one doesn't have to pay $50. Right?
Yeah.
So on one of the graphs, it would start at $50 and then
And it's gonna go up every month.
add a little bit, 0.2 cents per minute. And then on the other graph, it would start at $0 and add 20 cents per minute. Which one do you think is steeper, adding 2 cents per minute or adding 20 cents per minute?
It doesn't show you. I mean, I would say adding 20 cents per minute.
Yeah, because you got like for 1 minute you jump up 20 cents, but for the other 1 minute you jump up just 2 cents. So
the last one's not in.
yeah, the prepaid has a steeper slope. Prepaid phone plan will have a steeper line and lower y-intercept. That one I think is true because 20% or 20 cents is a steeper slope, But no monthly fee, that means it starts out at 0 each month. So the y-intercept is low. So maybe that's it. Let's see the rest of them. Well, it's definitely not the same steepness because 20 cents per minute is more steep than 2 cents per minute.
It's not going to have the same y-intercept as the. You're already at 50.
No, it won't have the same y-intercept because one starts at 50 for the month and the other one starts at 0. So both of those, yeah,
and the
I'm
last
gonna be
one's
wrong.
on 2.
Yep. Okay. So slope of -2/3. Do you know how to figure that out, like from each of these?
Yeah. So the 2/3 would be you go down or up, and then go over, right?
Yeah, on that one. But the slope, since it's negative, it
Oh yeah,
can't.
yeah.
The
It's gonna
answer
be one
can't
of these
be
guys here.
the first two answers because those are both positive. So.
It's got to be this one here because this is the y-intercept is at -2.
Oh yeah.
The other one goes at regular 2.
How would you count the slope on that one? Like, where would you do it with the mouse if you're gonna count it? What would you do?
I would go up 1, 2, and then over 3.
Yeah, and then that's 2/3, and it's going downwards, so it's negative. Perfect.
And if you were to do it here too, right? 1, 2, 1, 2.
Yep. As long as you can find a spot where it hits the graph exactly so that you can count it, then you're good. There's no graph. Oh.
Yeah, I was gonna say what the fuck is that?
Here, the y-intercept is 0 for all of the answers. Do you understand why there's no number adding?
It's just gonna be the rise and over, right?
Yeah.
Be 1/2. This one.
Um.
Well, no, because you go up. This is 2.
Well, how much do you like to get from that bottom corner? That's perfectly on the graph. The next
Yeah.
spot that's perfectly on the graph is 1, 4, right?
Yeah.
Okay, how do you
So
get
you
there?
go up 4, go over 1.
So which one is it?
The first one.
So remember the top number for the fraction would be the up and down.
That's the rise over, and then the run is the bottom right there. So it has to be 4.
There we go. Yeah, there just is no bottom number, but the bottom number is 1.
Okay. All right. So this one is the up and down, and then this one's the side to side.
Yeah, so that one would be less steep than the answer,
Yeah.
the actual answer.
So we know the 1 is the intercept.
Mm-hmm.
That'd be one of these two.
Okay, good.
And then the slope. So it'd be this one.
Mm-hmm. And the
Well,
slope
it's
for
going down to -2.
there you go. Yeah, and it's negative also, and that's the only one. That one wasn't so bad.
Yeah. See, these ones are good. These ones are actually kind of fun, and
Yeah, I feel like I don't know if they're more like the stuff that we've seen. That'd be good.
Yeah. I hope they get to, because I think the last course they got easier as we went on.
Yeah.
For some reason.
Um, okay, so
I'll show you the next one. We can do it tomorrow though if you have time. If not, I'll try to get her to unlock it. We'll see.
writing linear equations. Um,
I'll type it in my phone just so I can see if I can find any good videos on it.
yeah, there's a couple of ways that they might be talking about. I don't know if I can like say a quick thing, but does this mean so like if we get approved or you get the if your teacher unlocks the test, we could take the test, but if not, then we could continue on with this one.
Yeah. So the only reason I don't know if she will is because on the 22nd, which was yesterday, they started their spring breaks for this week, and then
Oh,
so it starts next week. But the teacher's pretty cool, and if I have her like on this like little classroom chat thing, so I'll send her an email and like I think she's like super paranoid about COVID, so she's probably just at home. Yeah.
yeah. Okay.
So I think she will unlock it because during like summer she still unlocks some English classes for me.
All right. Cool. Well, then
I'll
we
send
could
her an
work
email
on
right now.
whichever one.
Yeah, and I mean, if you're busy, let me know. But if not, I'll try to figure it out. I'll watch some videos. I'm down tomorrow if you are.
Yeah, I am.
All right. Thanks, man.
All right. Have a good one.
Good night.